Hi, let's get started. All right, so today we're going to talk about the subtraction of whole numbers. This is going to be the first of two parts, and I think what's going to actually happen the rest of this chapter anyway is every section is going to be two parts. The first part is going to be all the general stuff, all the methods and the models and the algorithms, and then the second part will just be me working through examples with different bases. I think that's how it's going to fall out here. Anyway, let's get started. So the first thing we want to talk about is the fact that subtraction is based on the idea that it's an inverse function. It's an inverse operation, which means that it undoes some other operation. In this case, subtraction undoes addition. We also are aware that division undoes multiplication and so forth. So those are some other examples of inverse operations, but we're going to lean heavily on the fact that it's an inverse operation here in defining subtraction in some of the models. So the official definition of subtraction of whole numbers is for any whole number A and B such that A is greater than or equal to B, A minus B is the unique number C such that B plus C is equal to A, where A is the minuend, which is the number that you're being subtracted from, and B is the number being subtracted, which is the subtrahend. Okay, and make note of those two things because I'm going to refer back in many examples here on the subtrahend and the minuend. All right, so basically we're going to talk about four main models. We're going to talk about the takeaway model, which is usually that first exposure done with manipulatives on their desk in class where they can put a certain number there and then take away a certain number, removing them from the pile and being able to count again. It's best done with manipulatives, but again, it can also be done with pen and paper. Then there's the measurement model. That one is always, we're going to almost be able to apply the measurement model to almost any operation we're going to deal with. And this model is effective once a student is comfortable with the number line, right? If they don't know what number lines are yet and things like that, then that is not going to be the model to choose, and something like the takeaway model would be better suited for that situation. Also, like the measurement model in addition, we use arrows in the measurement model here with subtraction. However, those arrows are going to indicate direction. So it'll be a little bit different, but still very visually appealing to people. There is also the missing addendum model, which I think a lot of times people actually subtract this way, which is pretty much adding up to the number that they're trying to get to from one of the, probably the minuend. Anyway, this model is super effective with mental math. Some students see it really well. It's definitely the way to deal with other bases because they're not as comfortable as 10. And keep in mind here that it's kind of hard to break out of that standard algorithm and the way you've always learned how to do it and the way you do it. But remember, as educators, you have to be able to bring multiple models, algorithms, ways to work problems to your students. You can't always be done the way that you're thinking because everyone thinks a little bit differently. And then finally, there's the comparison model. I think that this one I should have put up there next to the takeaway model. It's also a model that can be used in early days before you're really putting together some numbers. In this model, you make two sets and you kind of compare them off and strip the matches from the two sets off, and then you're left with what is left over, and then you count that up. Let's look at a few of these models with some examples. So first, the takeaway model, and I'm going to do it with a concrete model. Let me get down here and turn on my pen. I'm actually in my office today. I'm usually lecturing to you from my home office, but I'm actually at school right now. So anyway, so that's why I look a lot different in the background. I'm sure it's different as well. Okay, so I'm going to do the takeaway model here, and I'm going to use a concrete method, and that would be something like some manipulatives. Here I don't have the manipulatives, so we're going to use my very famous stars. So we're going to get us 8 stars here. And you have to imagine that if you're doing this with manipulatives, they have all these things. If you're not doing it with manipulatives, it's helpful to have more than one color going on. So this is our set of our 8 stars. And if we're taking away 3, I'm going to come in here with another color, and I'm going to circle up the 3 that we're taking out and indicate with an arrow that they're coming out, and then we're left with what is left there, which is 1, 2, 3, 4, 5. Do another example again. You don't actually want to make all your stuff look absolutely perfect. A lot of times students get hung up on making it look like the teacher looked, or making it look really, really perfect, and then that actually inhibits their ability to get busy with it. So here, not perfect for sure. We're going to circle up 4 of the stars. It doesn't matter. Do they all have to be next to each other? No, but in this case, it certainly helps if they are next to each other, because you know, it looks like you're like grouping some out and pulling them out there. So this also is equal to 5. Okay, let's take a look at the next one. The next one is a measurement model. Now, most importantly in the measurement model is you do need to make sure that your number line is nicely noted, and I didn't want to spend the time doing that on PowerPoint, so I thought I'd just draw it real quick. Okay, so for the measurement model, what we're going to do is we're going to take our menu end, and we're going to make a line getting us all the way to there, and that indicates 8. And then to do subtraction, if we were doing addition, we would pick up again right here at the end of this arrow, but because we're doing subtraction, we're going to do an arrow going the other direction for the number of units that we need to go, and that's 1 unit, 2 units, 3 units. So this is showing 8 minus 3, and then a lot of times it's great if you go ahead and show what this distance is, kind of reinforcing this 8 minus 3 notation. And that is equal to 5. And I don't know where my pen went. Okay, there we go. Okay, I'll do it again over here. Starting with 0. All right, and we'll do the same thing. We go all the way through and we place the menu end. So step 1, draw the menu end. And then the second step, starting from the end of the menu end and going in the opposite direction, draw in the subtrahend. And then finally, it's just really good practice so they really understand what this area leaves us to is this 9 minus 4 is equal to 5. And it is important for you to write these numbers in, especially in early days, so that they know what each one of these lines accounts for. Also, you know, color is very, very helpful. Changing color, visual people see it really well. The next model is kind of weird, but it actually works pretty good, and it's the missing addendum model, which basically, and we're going to combine it with the measurement model in a minute on one of these examples, but basically it's you thinking about what number do you need to add in to get to that next number. And so the way that we handle 8 minus 3 is we say 3 plus something equals 8. And this is a lot of, like I said, a lot of times people do subtraction like this. And so 3 plus, as we know, is 5 equals 8. But really what we're representing here in this box is that 8 minus 3. So when we decide that it is 5 here, that actually gives us that subtraction. Let me show it to you in kind of like a measurement model here. Okay, and we're going to do just like we did that last measurement model. We're going to put the minuend in. And then we're going to pick up with the subtrahend. And when you make this last piece here, we're going to write it like oh, I did that the wrong way. Oh, darn it. Okay, sorry, y'all. I don't want to start all over again, but I'm going to erase this because I didn't look at my notes and there's so many different models. Let me show you that I did it the wrong direction. So rewind. And here we go. Again, we start off with the minuend. And with the missing addendum model, when we do the subtrahend, it starts at 0. And then this other piece we would be able to designate as blank plus 4 equals 9. So the blank is the answer. This is the difference. This is the subtrahend. And this is the minuend. So that's the way that you can set it up doing the missing addendum model. Okay. The cool thing about the missing addendum model is that it fosters algebraic reasoning. It fosters and encourages algebraic reasoning. Okay, and that is You might be thinking, oh, algebraic reasoning, they don't need to do that until they're older. No, algebraic reasoning is a concept that's in the cores in first grade. So that doesn't go away. I think there might be one more. Yeah, the comparison model. Okay, now the comparison model is usually given or utilized in word problems and stuff. And generally, subtraction problems and addition problems are introduced to students as word problems. So let's take a look here. My first one on the left says Mark has 8 blocks and Sam has 3 blocks. How many more blocks does Mark have over Sam? Well, in the comparison model, we build 2 sets. One is the minuend, and one the subtrahend. Let me improve that. One minuend and subtrahend. All right, so here I am. I'm going to make my minuend. That's 8 blocks. So there's my Mark set. And then Sam has 3 blocks. There's Sam's set. Now I have them circled up. Not only are they 2 different colors, but they're circled up to indicate that those are complete sets. Even with 2 different colors, you need to be sure to circle things up here so that they understand that it's just not willy-nilly and it's very clear. Now what the comparison model tells us to do is to then compare by marking things out one for one. So for this 1 star, I can mark off this 1 star. For this 1 star, I got this 1 star. For this 1 star, I got, say, this 1 star. And then you're left with what is left. So once the subtrahend is empty, once you cross out all in the subtrahend, then the remaining should be in the minuend is the difference. Okay, and so here we have 5. And if we were going to write this, we would say 8 minus 3 equals 5. All right, and I have the same thing over here. There were 9 donuts in a box, and now there are only 5 left. How many donuts have been eaten? Again, the same thing. We're going to make ourselves a set of 9. And you can see where this could be really good with some actual physical manipulatives. You get yourself a pile of 9 here, and you got yourself a pile of 3 or 4 or 5. I can't remember. Sorry, didn't look. But we got your pile of 9 here, and you got your pile of 5 here, and then you're literally matching one from each pile, matching them up and taking them out. That's another way to do that comparison with some physical things. And then 5. Grouping it up. And then we can just start canceling them out. So this guy to this guy, this guy to this guy. You want to start in the subtrahend. I'm sorry I started not in the subtrahend there, but remember that the whole idea is to cancel everything out of the subtrahend, and what's left in the minuend is our answer. So we have 9 minus 5 is equal to 4. Okay, again, this might seem silly, repetitive, like why are we doing it like this? But we're going to be meeting students where they are, and sometimes even if they're in 3rd grade, they're not really doing 3rd grade stuff. Okay, so you need to be sure that you've got plenty of tools in your toolbox so you can pivot and be able to address the needs of a particular student. Okay, subtraction algorithms. So let's knock out some of these algorithms. The first algorithm, and almost always the first algorithm we're going to deal with, is going to be with base 10 blocks. Okay, so here we are with 243 minus 61. We're going to do them in our base 10 blocks. We've been messing with base 10 blocks for a little bit now, so we know that the unit stands for 1, the long stands for 10, the flat stands for 100. So we are going to draw our 243 out. So we have 2 flats, 4 longs, and 3 units. And then we're going to subtract, and I'm going to do this in a different color here, 61. So that means we're going to have 6 longs, and 1 block. Okay, so this is what we've got here, and remember that we're going to start with 1s and work over the other direction. So let us start with our 1s first here, and we're going to do it similar to the comparison model, and we're just going to cross them out. So this one cancels with that one. So we're done with the 1s. We're left with 2 1s. Now remember, we're taking away, so when we get over here to the 10s, we see that we have 6 10s to take away 4. Well, we can't do that, so we're going to have to borrow. We're going to have to exchange one of these flats for 10 longs. Okay, so now we can do our business down here with these 6 longs. That one's going to cancel with that one. We get to just cancel them out here, nice and easy. So what are we left with? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 of those left. And there's no flats to take away from this flat, so we're left with a flat. So our answer is 182. Okay, let's do a couple more, but I'm not going to be drawing all these blocks. Let's do them using the words flat, long, unit, because that's way easier for me to be able to do here. Okay, so let's look at 371 minus 42. So here for 371, that means that we have 3 flat, 7 long, 1 unit, and we're going to be taking away 4 long and 2 unit. And your textbook kind of writes it like this, and I do kind of like it. We're taking all of those away. Okay. Now, when we take a look here, we have 2 units to take away from 1. Well, we can't do that. We're going to have to change that 7 into a 6 and make this now 11 units, adding 10 to that unit. So now we can say 2 minus 11 is 9 units. Moving on to the next, here we have 4 longs out of 6 longs. Oh, nice. So we're left with 2 long. And because there's nothing to subtract here from these 3 flat, we're left with 3 flat. So our answer is 329. Let's do that again. With 1 flat, 1 long, 1 unit. You can see we're going to have to do some exchanges here for sure. Minus 3 long and 5 units. Okay, so right off the bat, we can't take 5 from 1. So this long is going to become no longs. And this 1 unit is going to become 11 units. So 5 minus 11, or 11 minus 5 is 6 units. Then we'll move over here and take a look, and we're like, okay, 3 units from no units, can't do that, so that flat's going to go away, and that's going to make that 10 longs, and 10 minus 3 is 7 long. So our answer is 76. Okay. All right, let's take a look at the expanded form. And expanded form is one of those also that kind of seems silly, like why are we doing the expanded form? But it promotes a lot of understanding and algebraic reasoning. So we're going to do it. All right, so let's look at this first guy in expanded form. When I say expanded form, that means that we're going to write these guys in like sums. So it's going to be 2 times 10 squared plus 4 times 10 plus 3 times 10 to the 0 power. And now let's subtract from that minus, and again, kind of got this idea going on here. And we're going to subtract from that 6 times 10 plus 1 times 10 to the 0 power. Now we're going to have to do some borrowing here. But we can do this first one here. 3 minus 1 is 2. So we got that guy, right? And then when we come here, we cannot take 6 out of 4, so we're going to have to borrow here. This is going to be 1. This is going to become 14. And 14 minus 6 gives us 8. And then don't forget, in this case, we have 1 of these 10 squares left. So our answer is 182. Check this out here. So this is 1 times 10 squared plus 1 times 10 plus 1 times 10 to the 0 power minus this crap. 3 times 10 plus 5 times 10 to the 0 power. Now we kind of know how this is going to go because we've done this problem a couple of other ways, but let's take a look here. First, we cannot take 5 from 1, so we're going to have to turn that into none and this guy into 11. And this is 5. 11 minus 5 is 6. Here we cannot take 3 from nothing, so we're going to have to make a change here, and that 0 tens turns into 10 tens, and 10 minus 3 is 7. So our answer here is 76. All right, let's see. Now we're going to start talking about, hold on, let's see where we are. The equal additions algorithm. Now this one I've got a few examples of because, again, this is an important algorithm, but it requires you to do a few of them before your brain sticks to it. So let's look at the equal additions algorithm. This technique depends on the fact that the sum or difference between two numbers doesn't change if we add the same amount to both of the numbers, to the minuend and the subintegrand. Okay, and or the add-ins if we're actually doing addition, right? So let's take a look here. And this might be a little bit familiar to you. This first example doesn't really go into the depth of it, but it gets you kind of thinking in the way that we're going to be thinking here. And the idea here is to make everything kind of as easy as possible and turn that subtrahend into a nice, pretty number that's easy to subtract. So the first thing I'm going to notice here is if I add 3, I'm going to get a nice, pretty multiple of 10. So this is going to make 96 minus 30. 96 minus 30 is equal to 66. So we just made it so much easier to do that math, not having to borrow or do anything like that. Okay. Now, a lot of times this isn't done in one step. A lot of times you're going to do this in a two-step process. Let's look at this next example. So the first thing I want to do is I want to add 7 in. When I add 7 in, this becomes negative 170, and when I add 7 here, this gives me 262. Now that doesn't really make the subtraction much easier. Still, we're having to borrow. So we want to do this a second time through, making that denominator be a whole number. In other words, have nothing but the highest placeholder digit and the rest be zeros. So what can we do here? Well, we can add 30, and that's going to make this a negative 200. And when we add 30 up here, this is going to give us 292. And when we do that math there, we see that the difference is 92. Okay. Let's do a couple more. Like I said, it helped for me to work a lot of these problems. And how did I do it? I just made up subtraction problems and I tried to follow this method. And how was I sure that my answer was right? I would subtract the way that I already know how to subtract and double check my answer. Okay, so you guys, if I demonstrate a type of algorithm or a model to you that you don't understand, well, you can very well just work on it on your own. So let's continue. So I did put some words to it here. First, you're going to focus solely on the subtrahend. This is often a two-step process, okay? You're going to get that single digit over, and then you're going to move the tens place. So you're going to move the ones place to a 0, and then the tens place to the 0. Or maybe you have to do it 3 times. You got to move the ones place to a 0, then do the addition to make the tens place a 0, and then maybe you got to do the addition to make the hundreds place a 0. It's going to be like that, okay? So it's all about rounding up to some kind of multiple of 10 to make it easier. So let's look at this first guy here. So I'm going to add 9. This is going to give me 252 minus 70. That should be to some degree easy enough, but this method actually encourages us to go ahead and add 30 again to make this 282 and make this 100, and that made it a whole heck of a lot easier. Oh, sorry, there's a 1 there. Yeah, my bad. Okay. Let's do this other one here. So first things first, looks like we need to add 8. So this becomes minus 150, and when we add 8 up here, this is 333. I don't know why I put that bar there. Hold on, let me just erase all this. Let me get back in the groove. Okay, when adding 8, this will become negative 150. Adding 8 up here, this becomes 308. Adding 8, 333. That's still not very pretty. We can add 50. This will give us 383, and that'll make this 200. And that makes it a whole lot easier. Okay. All right, and this also works for addition as well, you know, and a lot of times you want to deal with things that have zeros in them. This next algorithm is called the counting up algorithm, and it requires you to kind of add up the subtrahend to the nearest nice number, usually a multiple of 10, and then take that sum and add up to the minuend, and those two additions are added to make the difference. So let me just show you. It's definitely something that needs to be demonstrated. So you start off with the subtrahend, okay? You're going to add some number to the subtrahend to make it a pretty number. And so in this case, I'm going to add a 9. Because 31 plus 9 gives me a pretty number, which is 40. And now we take this 40 and we write it here. And we're going to finish this box off with 40 plus what is equal to 100. And that would be 60. And so the difference here is these added up, which is 69. I know, it's crazy. You might want to, I'm only going to have time to do a couple of these, and then we've got like just a couple more things and we'll be done here. Okay, so let's take a look at the next example here. So it says start with the subtrahend. So we're going to start with 56, and we need to add something to make it a round number. So we're going to add 4. 56 plus 4 makes it 60. And then we're going to take this 60. We're going to write it down here, and we're going to say 60 plus what equals 78. And that's going to be 18. And so 4 plus 18 is 22. And that tells us that 78 minus 56 is 22. I got to tell you, no lie, I thought this was slick. And I am terrible at subtracting. I really, as bad as I am at arithmetic, I'm really bad at subtracting. You'll find me busting out my fingers and my toes. So I thought that this was a pretty cool and slick trick. All right. And then we have, I think this is our last one. Looks like the last slide, the trades first algorithm. And what this technique does is it makes you do all of the trades before you actually perform it. And we're going to do it and I can't remember the name of it, but it's kind of like the expanded algorithm, but not exactly. And I really wish I'd looked up that name, but right now I can't think of it. So let me just show you. So we've got hundreds, tens, and ones. And I just can't remember what this is called, but we've certainly done it already. We did it with addition. So if we're going to start with the number with 122 minus 37, so we've got 122, and we are going to be subtracting 37. So leaving a little space down here, minus 37. And what we're going to do here in the middle is do the trades. Okay, so we notice we can't take 7 from 1, so we're definitely going to have a trade here. That makes that 12. And then you look here and we say we can't take 3 from 1, so we're going to have a trade here as well. And once all the trades are complete, then you can just get the answer. So 12 minus 7 is 5. 11 minus 3 is 8. And our answer is 85. All right, that gets us, we did it. I will get the second part up, and then I will get the multiplication lectures up just ASAP here before the end of the day tomorrow. I'll have them all done. Okay. All right. Thanks. Y'all have a good day, and I appreciate you.